Hi, I'm Mina.
And I'm Yules.
Thanks for tuning in to Artificially Informed.
So right now, floating up in the vacuum of the International Space Station, there is this tiny cloud of atoms.
Right.
And the National Aeronautics and Space Administration, so NASA, is basically maintaining this cloud to be, well, quite literally the coldest thing in the known universe.
Yeah, it is colder than the deep, empty void of space itself, which is wild.
I mean, that is just completely mind-blowing to think about. And they are doing it because mastering that level of extreme cold, it might actually be the only way humanity builds a completely physically unhackable computer.
It really sounds like science fiction, I know.
Yeah.
But it is pure bleeding-edge quantum mechanics.
Yeah.
And, it is a perfect example of how pushing the absolute boundaries of our physical reality up in orbit is going to fundamentally rewrite how we process information down here on the ground.
Welcome to the deep dive. We know you are tuning in because, well, the world is moving at a blistering, almost incomprehensible speed right now.
It really is.
And you don't want just a shallow read of the headlines, or
Right.
You want to understand the mechanics underneath them. You want to know how all these pieces fit together.
Exactly.
So today we are tracing this massive, complex web of human adaptation. We are looking at everything from that quantum deep freeze in low Earth orbit to 3-billion-year-old asteroid scars out in the Australian outback.
Oh, and don't forget the geopolitical chess matches that are currently rewriting the global supply chain for artificial intelligence.
Right. There is a lot of ground to cover. I mean, we are talking about everything from quantum physics to high-stakes political reality TV. But do not worry, we promise to leave the heavy jargon at the door.
The overarching theme tying all of this reporting together today is humanity's relentless friction with a universe that simply refuses to stay still.
Yeah.
Whether it is astrophysicists measuring the expansion of the cosmos, or diplomats navigating the really tense waters of the Strait of Hormuz, or even scientists deciphering an outbreak in the Democratic Republic of the Congo.
We are constantly forced to adapt, right? Our tools, our laws, our entire understanding of reality.
Precisely.
So I want to start by looking up, like way up. Let's talk about the fundamental fabric of the universe itself.
Let's do it.
According to recent astronomical reporting, astrophysicists are collectively breathing this massive sigh of relief. And that is because a major theoretical crisis regarding dark energy has apparently been averted.
Right. The data shows dark energy is still accelerating the expansion of the universe in this predictable, steady way.
But honestly, I always struggle a bit with the framing of this. Why is it called a crisis when we find a discrepancy in our models? I mean, if the universe is doing something unexpected, isn't that just a new discovery waiting to happen? Isn't that the whole point of science?
Well, it is a fair pushback. I mean, in a vacuum, discovering new physics is the ultimate goal. But you really have to understand the sheer weight of what we call the standard model of cosmology.
Okay, break that down for me.
So specifically, the lambda CDM model. Dark energy, which makes up roughly 68% of the universe, is represented by the cosmological constant.
Right.
And for decades, our entire mathematical scaffolding for how the universe evolved from the Big Bang, how galaxies form and the ultimate fate of the cosmos, it has all relied on that energy being truly constant.
So it was like a load-bearing pillar in the house of physics.
Exactly, a massively load-bearing pillar. So recently, some highly sensitive measurements suggested what we call the Hubble tension.
Which is what exactly?
It is basically a discrepancy in how fast the universe is expanding, depending on where and how you measure it.
Oh, wow.
Yeah. And if that tension proved that dark energy was dynamic, like that it evolved or changed its strength over billions of years, we wouldn't just be adding a new wing to the house of physics. We would essentially have to dynamite the foundation.
Okay, I think I get it. I am picturing a massive invisible person blowing up a balloon. We know the balloon is expanding, right?
Yeah.
So the crisis would be realizing that this invisible entity might suddenly start blowing harder, or stop entirely, or, I don't know, maybe even start inhaling.
That is a highly effective way to visualize it, yeah.
So the new data basically confirms that this invisible force is exhaling at a totally steady, reliable rate.
Yes. The rate of inflation remains locked. It means our instruments calibrated to measure the deep cosmos can still trust the fundamental math.
Well, that perfectly bridges to my next point, actually, about calibrating our instruments.
Yeah.
There was coverage recently on the flyby of an interstellar comet named 3I-ATLAs.
Oh, yes.
And this is a chunk of rock and ice that originated entirely outside our solar system. which means it is older than our sun.
Which is incredible in itself.
Right. Naturally, the search for extraterrestrial intelligence, or SETI, trained their massive radio telescopes on it. They were looking for any sign of non-natural, structured radio emissions.
Right, they were basically checking if this ancient comet was actually an alien probe masking its signature.
Exactly. And the scan came back completely negative. They heard absolutely nothing but our own human-made interference.
And this is standard operating procedure now for any interstellar interloper. We did the same thing with Oumuamua several years back.
Right. But wait, if they detected nothing but human interference, that actually sounds like a stress test for our own gear, doesn't it? Like, if we can successfully isolate Earth's radio smog from deep space noise, it proves our filters are working.
You have isolated the exact reason this negative result is highly celebrated in the astronomical community. A non-detection is actually really robust data.
Because we are so noisy.
Exactly. Earth is phenomenally loud in the radio spectrum. I mean, we have thousands of commercial satellites, military radar, cell towers. It creates this blinding glare for radio astronomers.
I can imagine.
So the fact that SETI algorithms could effectively subtract that human-generated glare, look at an object light minutes away, and definitively state there is no anomalous transmission, well, it proves our signal processing software is operating at an unprecedented level of fidelity.
So when a genuine signal finally does hit our detectors, we will know for a fact it isn't just, say, a misconfigured Starlink satellite pinging the wrong frequency.
Precisely. And it also secures the comet's status as a pristine natural time capsule. Planetary scientists can analyze it without worrying about the lingering variable of artificiality.
That idea of isolating signals in extreme environments, it brings me right back to the NASA Cold Atom Laboratory on the ISS.
The Bose-Einstein condensates.
Yeah, they achieved these condensates at 1 picoKelvin. Let's unpack the mechanics of this, because I know Bose-Einstein condensate is this bizarre state of matter where atoms stop acting like individual particles, right?
Yes, they sort of blur together into a single quantum wave.
Right, but why do we have to go all the way to space to study it? I mean, can't we just build a really good freezer down here on Earth?
Well, the limitation isn't the temperature itself, it is gravity. Yeah. When you use lasers and magnetic fields to cool a cloud of rubidium or potassium atoms down to a billionth of a degree above absolute zero, which is what a picoKelvin is, that cloud loses almost all its kinetic energy.
Okay, so it gets very still.
Very still and incredibly delicate. If you do this in a lab on Earth, gravity immediately takes hold. The quantum cloud sags, it falls out of the magnetic trap, and just smashes into the walls of the vacuum chamber in a fraction of a second.
Oh, wow. So your observation window is basically nothing.
It is agonizingly short.
So in the microgravity environment of the ISS, the cloud doesn't fall. It just hovers there in the center of the trap.
Exactly. It hovers, allowing scientists to expand the cloud and observe its macroscopic quantum wave functions for seconds at a time. And in quantum mechanics, holding a coherent state for several seconds is practically an eternity.
That is fascinating.
They can use optical lattices, which are basically intersecting laser beams that create a carton-like structure of light, to trap and manipulate this ultra-cold matter without gravity ripping it apart.
Okay, so now, connecting the dots for you, the listener. Why does studying a hovering, super cold cloud of rubidium atoms in space actually matter for our technology on Earth? I brought up unhackable computers earlier.
Right, because manipulating a Bose-Einstein condensate is the foundational stepping stone for topological quantum computing.
Okay.
Traditional computers use bits, ones and zeros. Quantum computers use qubits, which can be a 1, a 0, or both simultaneously.
Right, the superposition.
Exactly. But the problem is that qubits suffer from decoherence, meaning the slightest vibration or heat destroys the data.
So they are incredibly fragile.
Extremely. By studying these ultra-cold quantum states in space, we are learning how to build error-correcting quantum architecture, and this eventually leads to encryption algorithms that are physically bound by the laws of quantum mechanics.
Meaning if a hacker tries to intercept the data.
The very act of observation fundamentally alters the state of the system, instantly alerting you to the breach. It is physically impossible to copy the data without destroying it.
That is incredible. And beyond computing, this also has massive implications for navigation, right? I read that quantum sensors could eventually replace GPS.
Yes, that is actually the more immediate, tangible application. Quantum inertial navigation systems use the wave-like nature of these ultra-cold atoms as highly sensitive accelerometers and gyroscopes.
How is that better than what we have?
because they measure acceleration at the quantum level, they don't drift over time like classical mechanical gyroscopes do.
Oh, I see.
You could put one of these quantum compasses in a submarine, dive down into the Marianas Trench, cruise underwater for a month, and know your exact position down to the millimeter without ever surfacing to ping a satellite.
It is so wild that the quiet, delicate physics of the microscale is currently dictating the future of macroscale global navigation.
It really is.
But, while NASA focuses on the quiet quantum realm, the physical space around the ISS is becoming intensely noisy and crowded.
Oh, absolutely. The commercialization of low Earth orbit is moving faster than almost anyone predicted even 5 years ago.
Yeah, recent space sector coverage highlighted a launch from Vandenberg Space Force Base in California, United States. A SpaceX Falcon 9 just put another 24 Starlink satellites into orbit.
Right.
Concurrently, there was this striking photo circulated by astronaut Jessica Meir. It showed the commercial SpaceX Dragon capsule undocking from the ISS.
A very symbolic image.
Very. And on top of that, NASA just awarded $476 million through their commercial satellite data acquisition program to private startups like Hydrosat and Orbital. It really seems like the era of the government-owned space monopoly is totally dead.
It is dead. And the mechanism replacing it is the public-private service contract.
Explain how that shifts the dynamic.
Well, historically, if NASA or the Department of Defense wanted, say, multispectral thermal data of the Earth's surface, they would initiate a cost-plus contract.
Okay.
They would design a bespoke satellite, hire a prime contractor to build it, absorb all the cost overruns, and operate it themselves. It took a decade and cost billions. Now, venture-backed startups are building proprietary constellations of small satellites using off-the-shelf components. NASA essentially looks at the market and says, hey, we need high-resolution thermal infrared data to monitor agriculture. Who has it?
And they just buy the data feed.
Exactly, as a subscription service. Handing out $476 million to private companies isn't just cost-saving. It drastically accelerates the pace of innovation.
Because they have to compete.
Right. These startups are competing on capability and price rather than just lobbying for a single massive government contract.
It makes sense financially, for sure. But when you privatize a domain like space, you introduce an entirely new layer of geopolitical anxiety.
You really do.
There was also a report about a Chinese space plane that recently released a mystery object into orbit. Now, if the sky is filled with thousands of commercial satellites, tracking a classified military object becomes a total needle-in-a-haystack scenario.
This is the core dilemma of modern orbital mechanics, the dual-use nature of space hardware.
What do you mean by dual use?
Well, a space plane deploying an object is an action devoid of inherent context. That object could be a totally benign weather sensor, a communication relay, or a microgravity experiment.
I sense a but coming here.
But the physical mechanics required to maneuver a benign sensor close to another satellite to inspect it for repairs, well, those are the exact same mechanics required to build a co-orbital anti-satellite weapon.
Oh, wow. So an inspector satellite?
Can act as an espionage tool, intercepting tightly beamed communications, or it can literally be a kinetic kill vehicle.
Right.
Because there is zero transparency and because the volume of orbital traffic is just exploding, strategic ambiguity breeds a lot of paranoia.
I keep thinking about the Kessler syndrome.
Oh, yes.
That idea that a single collision in orbit could create this cascading debris field that wipes out entire orbital shells. If we have this massive crowding of commercial satellites alongside classified mystery objects, it feels like we're operating a highway at 17,000 miles per hour with absolutely no traffic laws.
We are essentially operating under the Outer Space Treaty of 1967.
Which is pretty old.
It is a document drafted when reaching space was the exclusive domain of two superpowers, and commercial spaceflight was literal science fiction.
Right.
The treaty prohibits placing weapons of mass destruction in orbit, sure, but it is woefully silent on the regulation of inspector satellites, commercial mega-constellations, and just general space traffic management.
So until the international community establishes a new framework,
the risk of a miscalculation where a nation mistakes a close-approach commercial maneuver for a military attack remains uncomfortably high.
Well, let's bring our focus from the vacuum of space down to the solid ground. Satellites give us the ability to look down at the Earth's surface, but we are also making profound discoveries by looking at the deep geologic and archaeological record.
Earth is basically a massive weathered hard drive.
That is a great way to put it. Recent geological reporting identified the North Pole Dome in the Pilbara region of Western Australia. They are saying it is likely the oldest known asteroid impact crater on Earth, dating back roughly 3 billion years.
3 billion years is hard to even conceptualize.
It really is.
The Pilbara region is one of the few places on the planet where the ancient crust hasn't been completely subducted or recycled by plate tectonics. But finding a crater from that far back requires serious forensic geology.
Because of erosion, right?
Exactly. 3 billion years of erosion means there is no visible bowl or rim left to see.
So if it doesn't look like a crater, how do they actually prove an asteroid hit there?
They look for the microscopic ballistic signatures of extreme trauma. Specifically, they look for shocked quartz.
Shock quartz.
Yeah, when an asteroid impacts the crust, the instantaneous massive spike in pressure and temperature reorganizes the crystalline structure of quartz into high-density forms. You only find those structures at ground zero of nuclear detonations or cosmic impacts.
Oh, wow.
By isolating these shocked minerals and dating the crystals embedded nearby, they can pinpoint the exact epoch of the impact.
And 3 billion years ago puts this right at the tail end of the late heavy bombardment.
It does.
It really paints a picture of early Earth, not as this tranquil incubator, but as a violent apocalyptic shooting gallery where early single-celled life had to constantly restart.
It frames biological resilience in a major way, and we see that theme of adaptation against shifting environments echoed in much more recent paleontological finds as well.
Let's talk about those. There are reports on 2 massive natural time capsules. First, a million-year-old cave system in the Waitomo region of New Zealand revealed fossils of 12 extinct bird species and 4 frog species.
Yes.
Second, over in Liaoning province in China, paleontologists uncovered a 4-winged dinosaur named Jianchengmansis.
Both incredible finds. The Waitomo cave discovery in New Zealand is vital for climate modeling, actually.
How so?
Caves act as perfect sediment traps. Over 1 million years, as the external climate shifted wildly due to glaciation and volcanism, animals sought refuge in these caves or their remains were just washed in.
Right, they get preserved.
Exactly. By analyzing the stalagmites alongside the specific turnover of these extinct birds, scientists can map exactly how the local ecosystem collapsed and reorganized in response to rapid prehistoric climate change.
It is a stark mirror for our current ecological fragility, honestly. Now, the Jianchengmansis fossil in China, this 4-winged dinosaur, that completely challenges the linear view of evolution for me.
It does for a lot of people.
We are taught that small dinosaurs evolved feathers and eventually turned into birds. But having 4 fully feathered wings, 2 on the arms, 2 on the legs, that sounds aerodynamically chaotic.
It was incredibly aerodynamically inefficient compared to modern flight. Jianchengmansis represents a macroevolutionary dead end.
A dead end.
Yes, it illustrates that evolution is not this ladder climbing toward a perfected form. It is a sprawling, messy bush of experiments.
That makes a lot of sense.
4-winged gliding was a dominant adaptation for a brief geological window, but as the environment changed and the canopy structures shifted, 2-winged powered flight just proved more adaptable. The 4-winged lineage simply couldn't compete, so it went extinct.
Speaking of complex lineages, there was a flurry of recent discoveries mapping human history.
Yeah.
We are talking deep footprints here.
Oh, the archaeological developments are fascinating right now.
Yeah, researchers extracted 2,000-year-old human DNA from caves in Spain and Portugal. In Poland, underwater archaeologists pulled a 1,000-year-old haunting wooden face from Lake Letnica linked to the PS dynasty.
Right.
And near Rome, in Italy, a university team unsealed a completely untouched 2,600-year-old Etruscan tomb.
Each of these utilizes a totally different technological breakthrough.
Walk us through them.
Well, the cave DNA from Spain and Portugal relies on next-generation sequencing. Ancient DNA degrades into these tiny, fragmented strands. 20 years ago, we couldn't read them at all.
And now?
Today, computational algorithms can piece those fragments together, allowing geneticists to trace exact migration patterns of the Roman and pre-Roman populations across the Mediterranean.
That is amazing. And the wooden face in Poland.
That relies on advanced dendrochronology and radiocarbon dating. It anchors the mythological origins of the Polish state to hard, physical evidence found at the bottom of a lake.
But the Etruscan tomb in Rome, that fascinates me the most. Finding a sealed tomb from 2,600 years ago is incredibly rare because almost all of them were looted in antiquity.
It is the ultimate prize for archaeologists. The Etruscan civilization profoundly influenced early Rome. They gave Rome the arch, gladiatorial combat, much of their engineering.
But they left almost no written historical record, right?
Exactly. They are a civilization known primarily through their graves. So finding an untouched tomb means the contextual layout is perfectly intact.
They can see exactly how it was left.
Right. Archaeologists can analyze the chemical residue in the pottery to see what they ate, examine the placement of the bodies to understand their social hierarchy, and even trace the metallurgy of their jewelry to map out their vast trade networks.
That is the beauty of finding the physical objects. But, sometimes the object itself kind of mocks us.
Oh, you were talking about the Phaistos disk.
Yes, let's talk about the Phaistos disk. It was discovered in 1908 on the island of Crete in Greece, dating back to 1700 BC.
Right.
It is this baked clay disk covered in a spiral of stamped symbols. To me, it is the ultimate encrypted puzzle from antiquity. I mean, we have artificial intelligence that can fold complex proteins and write software code, yet we still cannot read a clay coaster from 3,700 years ago. Why is that?
Because AI requires massive data sets to identify statistical patterns. The Phaistos disk is a cryptographic anomaly. The symbols were pressed into the clay using pre-carved seals, making it one of the earliest known forms of movable type.
But we have no idea what language it is.
None. We don't have a Rosetta Stone for it.
Right.
To crack an unknown script, you either need a bilingual translation key or you need tens of thousands of words of the script so algorithms can apply Zipf's law.
Zipf's law.
It is a mathematical rule that lets you calculate the frequency distribution of characters to deduce grammar and syntax. But the Phaistos disk contains only 242 tokens.
Oh, wow. That is nothing.
It is simply not enough data for machine learning models to overcome the sheer combinatorial explosion of possible translations. An AI large language model fundamentally breaks down when given an isolated data point without a statistical neighbor.
So it is just lock.
Until we find another tablet using the exact same script, its meaning remains mathematically locked.
I actually find a strange comfort in that. Amidst all our processing power, the past still gets to keep a few of its secrets.
It is a nice thought.
But looking at the present, our processing power is being deployed to handle crises that are entirely unsecret and painfully visible. Let's pivot to the climate squeeze and the technological lifelines we are desperately trying to build.
The physical environment is applying immense pressure globally right now.
It really is. Multiple international outlets are covering the severe global weather anomalies driven by the strongest El Niño in 140 years.
Yes, Europe is currently baking under a massive heat wave.
Right. France just recorded its hottest night in recorded history. And the societal fallout is immediate. Tragically, 40 people drowned in France seeking relief in unmonitored waterways. And there have been widespread school closures to protect children from heat stroke.
The critical danger of this heat wave isn't just the daytime peak, though. It is the lack of nocturnal cooling.
Explain that.
Modern European urban infrastructure, vast expanses of concrete, asphalt, and stone, it acts as a massive thermal sponge.
Right, it just soaks up the sun.
Exactly. It absorbs solar radiation all day and slowly radiates it back out at night. When the ambient temperature doesn't drop below 25 degrees Celsius, the human cardiovascular system cannot reset itself.
Oh, I see.
This urban sheet island effect creates a compounding physiological crisis, particularly for the elderly.
Which makes a report I saw about the Trot cave homes in France so striking. These are ancient dwellings carved deep into limestone quarries in the Loire Valley in France.
Right.
People are living in them today, and residents report they act basically like a fridge during these brutal heat waves. It's this fascinating collision of prehistoric survival tactics and modern climate failure.
It perfectly demonstrates the physics of thermal mass. The Earth itself maintains a relatively constant temperature of around 12 to 14 degrees Celsius year-round, insulated from surface weather fluctuations.
So it is naturally climate controlled.
Exactly. The limestone naturally regulates humidity and temperature. The fact that modern citizens are retreating to medieval quarry homes really highlights a severe failure in our modern glass and steel architectural paradigm.
Because we rely entirely on air conditioning.
Right. Energy-intensive, active HVAC cooling systems rather than passive, sustainable design.
It really forces you to ask if we should be building backwards to survive the future. Meanwhile, instead of going backward, NASA is leaning hard into the future to mitigate weather disasters. They are utilizing a system called TANCLS, which uses machine learning to predict slash floods.
Yes.
Now, I understand that AI processes data incredibly fast, but how does an AI actually predict a flood better than a highly trained human meteorologist?
It comes down to the sheer dimensionality of the data and the type of algorithms used. Human meteorologists rely on linear models. They look at rainfall rates and river gauge levels.
Okay.
But a flash flood is a chaotic, nonlinear event. The NASA system uses recurrent neural networks. It doesn't just look at rain. It simultaneously ingests real-time soil moisture saturation from satellites, topographical elevation models, the permeability of local urban asphalt versus natural drainage, and historical storm runoff rates.
Wow. So it is looking at 100 invisible variables all at once.
Yes. The neural network can identify a highly specific, complex pattern, say a specific rain density over a specific gradient of drought-baked, impermeable soil that historically precedes a flash flood by hours.
Things a human could never spot in time.
Exactly. It finds the signal in the data smog that a human simply cannot compute. By shifting the warning lead time from 15 minutes to 3 hours, the AI transitions the situation from a mass casualty event to a managed evacuation.
That is the utopian promise of AI, right? Saving lives through hyper-efficiency. But we really have to look at the other edge of that sword.
The economic impact.
Yeah, there is deep reporting right now on what is being called the AI jobs paradox. While AI models are saving towns from floods, they are simultaneously carving out the tech labor market.
The numbers are staggering.
Over 150,000 tech jobs have been eliminated globally in the last 6 months alone. Oracle just announced a staggering 21,000 job cuts. Is this just standard corporate downsizing, or are we witnessing a structural automation of the workforce?
The data points very strongly towards structural automation. This is not simply a cyclical economic downturn where companies trim excess headcount.
It's something fundamental.
Right. Tech giants are explicitly reallocating capital away from human labor and directly into AI compute infrastructure.
Wow.
They are discovering that large language models and AI coding assistants can handle mid-level software engineering, quality assurance testing, and data analysis faster and with far less overhead than human teams.
The economic friction here is just brutal. Proponents always cite the idea that technology creates new jobs to replace the old ones. And sure, maybe in a decade we will have millions of, AI integration managers.
Right.
But for the 150,000 software developers who just lost their livelihoods right now, that transition period is economically devastating. We are deploying the technology without building the societal shock absorbers.
It is the defining socioeconomic challenge of this decade. The productivity gains of AI will be massive, but the distribution of those gains is becoming hyper-concentrated.
If we're talking about massive technological leaps that could rewrite our economy, we have to look at fusion power.
The ultimate lifeline.
Exactly. Commercial fusion startups like Commonwealth Fusion Systems and Helion Energy have raised an unbelievable $7.1 billion leading up to 2026. Helion is actually aiming to provide commercial electricity to Microsoft by 2028.
Which is an incredibly aggressive timeline.
It is. I have heard the joke my entire life, fusion is the energy of the future, and it always will be.
Yeah.
Why is there suddenly billions of dollars betting that the future is only 2 years away?
Because the underlying material science has finally caught up to the theoretical physics. To understand the breakthrough, we must quickly differentiate it from the nuclear fission we use today.
Okay, let's do that.
Fission splits heavy, unstable atoms like uranium, which creates chain reactions and highly toxic, long-lived radioactive waste. Fusion does the exact opposite.
It combines them.
Right. It takes light atoms, specifically isotopes of hydrogen like deuterium and tritium, and smashes them together under unimaginable heat and pressure to fuse into helium. This is the exact mechanism that powers the sun.
Right, so it releases immense clean energy, and if the machine breaks, it just stops. There are no meltdowns.
Exactly.
But containing a tiny sun on Earth is the problem.
It is the ultimate engineering bottleneck. You have to heat a plasma to over 100 million degrees Celsius, which is hotter than the core of the sun.
That is absurd.
And no physical material can hold that, obviously, so you have to contain the plasma inside a massive, invisible bottle made of magnetic fields.
Right.
For 50 years, it took more electricity to run the giant electromagnets than the fusion reaction ever actually produced.
So what changed to make Helion think they can hit net energy gain by 2028?
2 massive things. First, the development of high-temperature superconductors, specifically materials like YBCO, which stands for yttrium, barium, copper oxide. These allow us to build electromagnets that generate vastly stronger magnetic fields while taking up a fraction of the space and using significantly less power.
That is a game changer.
It is. And second, we are now using advanced AI to constantly adjust the magnetic confinement geometry in real time, preventing the plasma from collapsing.
Oh, so AI is controlling the magnetic bottle.
Exactly. Helion uses a specific approach where they fire two plasmas at each other to induce fusion and directly recapture the energy magnetically. If they achieve commercial viability, it fundamentally solves the global energy crisis. It provides infinite, dispatchable, zero-carbon baseload power.
That is the absolute holy grail of adaptation. But, transitioning global energy systems and dominating the tech sector doesn't happen in a peaceful vacuum.
No, it happens in the mud of geopolitics.
Exactly. Let's move into our geopolitical segment, because the competition for these foundational technologies is completely rewriting global alliances.
We see this vividly in the escalating tech wars right now.
We do. Recent reporting details how the U.S. government recently banned the AI company Anthropic from offering its advanced Fable 5 and Mythos 5 models, and this was due to security vulnerabilities flagged by Amazon.
Right.
Concurrently, China added 10 major U.S. firms to its export control list, specifically targeting companies heavily involved in rare earth mineral production.
This is an asymmetric, tit-for-tat economic conflict, and we really have to look at this impartially to understand the strategy on both sides.
Let's break it down.
The U.S. views advanced AI models not just as software, but as critical national security infrastructure. The concern is that an unsecured frontier model could be manipulated by state actors to launch automated cyber attacks or generate highly effective biological weapon blueprints.
Right, so the restriction is seen as a necessary defensive posture.
Exactly. Therefore, restricting the deployment of models like Fable 5 is viewed as protecting the homeland.
And China's response targets the physical layer of that technology.
Precisely. You cannot run a massive AI model without millions of specialized microchips. And you cannot build those chips without rare earth elements like neodymium and praseodymium.
Which China controls.
Yes. While the U.S. and other nations have rare earth deposits in the ground, China heavily dominates the incredibly complex, highly toxic chemical refinement process required to make those minerals usable for tech manufacturing. It is called solvent extraction.
So it's a mutual choke point.
Yes.
The U.S. restricts the software capabilities, and Beijing flexes its ability to choke off the physical supply chain required to build the hardware.
And that is why the markets are reacting.
It is no wonder the global tech stock market is experiencing massive volatility. If either side squeezes too hard, the entire global tech ecosystem grinds to a halt.
It is a textbook example of mutually assured economic disruption.
Now, this high-stakes maneuvering is mirrored in traditional diplomacy in the Middle East right now, too.
Very much so.
There's intense flurry of activity. U.S. Vice President J.D. Vance is currently in Switzerland conducting high-level talks with Iranian officials.
These are arguably the most delicate diplomatic negotiations currently occurring globally.
What is the main objective?
The core objective is establishing a verifiable framework to limit Iran's nuclear enrichment capabilities, while Iran seeks the lifting of crippling economic sanctions.
But the public messaging is completely fractured. U.S. President Donald Trump publicly claimed that Iran has completely agreed to comprehensive nuclear inspections.
Right.
Almost immediately, Tehran issued fierce denials, stating unequivocally that no such agreement has been finalized. How do you parse what is actually happening when the public statements contradict each other so sharply?
You parse it by analyzing the domestic political constraints of both actors. Diplomacy at this level is always a two-level game.
Meaning?
Both the U.S. administration and Iranian leadership are negotiating with each other in Switzerland, yes, but they are simultaneously negotiating with their own domestic political bases back home.
I see.
For the U.S. administration, claiming a definitive diplomatic victory on inspections projects strength and reassures a domestic electorate deeply concerned about Middle Eastern security.
And for the Iranian negotiators?
The Iranian delegation faces immense pressure from hardline factions within their own political establishment. Conceding to Western inspection demands, especially while under maximum economic pressure, is highly sensitive.
It looks weak at home.
It can be framed internally as a capitulation of national sovereignty. Therefore, a swift public denial of any major concession is a necessary political reflex to maintain domestic stability, regardless of the granular frameworks actually being discussed behind closed doors.
It is diplomatic theater necessary for survival. But beneath the theater, there is pragmatic action happening.
Yes, there is.
A U.S.-Iran Memorandum of Understanding just facilitated a massive operation by the UN International Maritime Organization. They are evacuating 11,000 stranded seafarers from the Strait of Hormuz.
That is the tangible result of back-channel pragmatism. The Strait of Hormuz is a global economic jugular. Roughly a fifth of the world's oil transits through it.
So any instability is a huge problem.
Massive. When geopolitical tensions escalate, commercial shipping insurers panic, vessels are detained, and civilian crews are caught in the crossfire. The fact that an OU was successfully executed proves that institutional guardrails are still functioning to prevent an absolute collapse of regional maritime trade.
And these regional dynamics are heavily interconnected. At the exact same time, in Lebanon, Israel and Hezbollah have formally agreed to renew a ceasefire.
Yes.
Does a localized ceasefire in Lebanon have a direct mechanical impact on the nuclear talks in Switzerland?
It has a profound impact because of the mechanics of proxy warfare. Hezbollah operates with significant financial and strategic backing from Iran.
Right.
When active kinetic warfare erupts between Israel and Hezbollah, the regional escalation ladder activates. The political temperature becomes far too volatile for U.S. and Iranian diplomats to sit across from each other in Europe.
Because their allies are shooting at each other.
Exactly. The ceasefire in Lebanon effectively acts as a pressure release valve. It de-escalates the immediate threat environment, providing the necessary diplomatic oxygen for officials to engage on the broader nuclear issues without the imminent threat of a regional war overshadowing the table.
It is a vast, fragile web of leverage. But, occasionally international relations strip away the grand strategy and reveal deeply personal friction.
Oh, absolutely.
There was a striking diplomatic incident recently. Italy's Prime Minister, Giorgia Meloni, abruptly canceled Foreign Minister Antonio Tajani's official state visit to the U.S.
Over a photograph.
The catalyst was President Trump publicly claiming that Meloni had begged him for a photo op during the recent G7 summit in France. Meloni furiously rebuked the statement as completely fabricated. I have to admit, seeing state visits canceled over a photo op dispute feels a bit surreal.
It does feel trivial when juxtaposed against nuclear negotiations, I agree. But in the realm of international diplomacy, personal dignity and public perception are critical assets.
Because leaders project the sovereignty of their nations.
Precisely. If a head of state feels publicly demeaned or misrepresented by an ally, failing to react projects weakness to both their domestic electorate and their international adversaries.
So canceling the foreign minister's trip was a calculated mechanism of protest.
Exactly. Italy is a cornerstone of the NATO alliance and a vital partner for the U.S. in managing Mediterranean security. When personal grievances derail the official mechanisms of statecraft, it creates a tangible lag in policy execution.
It really shows how fragile these alliances can be.
It demonstrates that the architecture of international alliances is heavily reliant on the unpredictable interpersonal chemistry of the leaders at the very top.
Speaking of the leaders at the top and how they project power, let's talk about the hardware of the U.S. presidency.
The new Air Force One.
Yes, the unveiling of the new VC-25B bridge Air Force One. But the unprecedented detail here is that this $400 million highly modified Boeing 747 was gifted entirely to the United States military by the government of Qatar.
This represents a massive departure from standard U.S. defense procurement protocols.
I could imagine.
Historically, presidential aircraft are sourced through highly regulated, deeply scrutinized domestic contracts, ensuring absolute transparency and security oversight from the very first rivet.
I just keep thinking about the security nightmare of accepting a foreign jet for the president. They can't just slap a presidential seal on the door and fly it.
Oh, the security retrofit is monumentally complex. The military and the Secret Service have to effectively strip the airframe down to the bare aluminum skeleton. They must guarantee there are no embedded surveillance devices.
Right.
Furthermore, an Air Force One operates as a flying military command center. It requires extreme EMP, or electromagnetic pulse, hardening to survive a nuclear blast, and it must be integrated with classified satellite communication arrays.
It is not just a luxury jet.
No, verifying the integrity of a pre-built foreign airframe to meet those standards is an immense engineering hurdle.
And beyond the engineering, the optics are intensely debated right now. I have read arguments on both sides.
It is very polarizing.
Proponents highlight that accepting the gift saves American taxpayers nearly $500 million and deeply solidifies a strategic military alliance with Qatar, which hosts vital U.S. air bases in the Middle East.
Right.
Critics, however, argue that accepting an asset of this magnitude from a foreign nation, particularly in a complex region, creates an inescapable appearance of undue influence or diplomatic leverage.
It is a debate fundamentally centered on the ethics of statecraft and the boundaries of strategic partnerships. It really tests the norms of how superpowers manage alliances and domestic optics simultaneously.
Okay, we have analyzed the high-altitude geopolitical chess matches, but we need to look at the global ripples.
The ground-level realities.
Exactly. When these international tensions boil over, the realities on the ground are stark, immediate, and unforgiving. Let's start with the escalation of the conflict in Ukraine.
The tactical reality on the ground in Eastern Europe is evolving at a staggering pace right now.
It really is. The UK is sending a massive package of 150,000 drones to the Ukrainian military. Crucially, this is being funded through a loan backed by frozen Russian sovereign assets.
A very significant detail.
Simultaneously, Ukraine has deeply integrated drone warfare into their offensive strategy. They recently executed strikes against targets within Moscow and heavily degraded fuel infrastructure in the Russian-annexed Crimean Peninsula.
What we are observing is the definitive maturation of asymmetric, unmanned warfare. The calculus of military power has been permanently altered.
Explain the economics of that asymmetry to me. How does a drone change the math so drastically?
It fundamentally upends the cost-exchange ratio of warfare. Historically, to destroy a multi-million-dollar main battle tank or a sophisticated radar installation, a military had to risk a multi-million-dollar fighter jet and a highly trained pilot.
Or use an incredibly expensive cruise missile.
Exactly. Today, an infantry unit can utilize an FPV or first-person view drone that costs perhaps $2,000. They scrap a localized explosive payload to it, and they achieve the exact same strategic destruction.
So the barrier to entry for precision strikes is just plummeted.
It has. When the UK commits to sending 150,000 drones, it signifies that drones are no longer specialized reconnaissance tools. They are the ubiquitous, standard-issue munition of the modern battlefield.
And Ukraine striking deep into Russia.
Ukraine's ability to consistently strike deep into Moscow and target the logistical lifeblood, oil refineries in Crimea, it demonstrates that drone warfare has effectively erased the concept of a safe rear echelon.
It's because they could just fly right past the front lines.
Right. The economic and psychological attrition of defending vast energy infrastructure against cheap, swarming aerial threats is immense. And funding this specific drone package via the interest on frozen Russian assets introduces a novel, highly controversial legal mechanism into the architecture of economic warfare.
It is a grim testament to technological adaptation in warfare. But we also see urgent, desperate adaptation happening in global health. There are reports on a severe surging Ebola outbreak in Africa. Specifically, the Bundibugyo virus strain is spiking by 40% across regions of the Democratic Republic of the Congo and Uganda.
The Bundibugyo strain of the Ebola filovirus is deeply concerning because of its high transmissibility and devastating hemorrhagic effects. But the World Health Organization, the WHO, is facing a crisis that extends far beyond virology.
Right. The reports note that the medical response is actively hindered by the socio-political collapse in the region.
Medical personnel are essentially fighting a two-front war. On one side is the virus, on the other side is active, violent, armed conflict between various militia groups in the eastern DRC.
So they are trying to treat patients in a war zone.
Epidemiologists and frontline doctors are attempting to run contact tracing protocols and administer experimental vaccines while literally navigating active combat zones.
And the conflict breeds an environment of absolute distrust. I read a horrifying detail where widespread misinformation and fear led to local communities actively attacking the hospitals.
It is tragic.
They believe the medical workers were somehow responsible for the disease. In one instance, a terrified family broke a 6-year-old Ebola patient out of a treatment center, effectively guaranteeing the child's death and risking massive community spread. It illustrates the absolute necessity of sociological integration in global health. You cannot arrest the geometric spread of a highly lethal virus with just sterile medical protocols.
Because the trust isn't there. The medicine doesn't matter.
Exactly. If the community architecture is shattered by war and institutional trust is replaced by paranoia, the epidemiological response fails. The WHO has to deploy medical anthropologists to negotiate with community leaders just to gain the physical access required to deploy the vaccines. Now, contrast that acute, visceral struggle for survival in the DRC with a completely different type of health crisis unfolding in the West.
A regulatory battle in Europe.
Right. The European Union has officially codified a sweeping ban on bisphenol A, or BPA, in all food packaging, which will take full effect by July 2026.
It is a striking juxtaposition of the varied threats humanity faces. While the DRC battles a rapid, visible pathogen, the EU is mobilizing against a slow, invisible, chronic chemical threat deeply embedded in modern supply chains.
Break down the mechanics of BPA for us. Why is the EU taking such aggressive regulatory action against the lining of soup cans and water bottles?
Bisphenol A is an industrial chemical crucial for manufacturing polycarbonate plastics and epoxy resins. The structural issue is that BPA molecules leach from the packaging into the food or water, especially under heat.
And why is that bad for us?
Biologically, BPA is a potent endocrine disruptor. Its molecular structure mimics estrogen, allowing it to bind to estrogen receptors throughout the human body.
And when an artificial chemical starts pulling the levers of our hormonal system, the downstream effects must be systemic.
Exactly. Decades of epidemiological data now link chronic, low-dose BPA exposure to a cascade of long-term health crises. We are talking severe fertility degradation, altered neurodevelopment in children, metabolic disorders leading to obesity, and cardiovascular disease.
Wow, so it is everywhere.
The EU's total ban represents a monumental pivot in public health policy. It is a regulatory acknowledgement that the chemical conveniences of mid-20th century manufacturing are causing unacceptable, multi-generational biological damage.
And that requires a massive logistical overhaul of the entire European food packaging industry.
It requires forcing a massive adaptation on the market to protect the population.
We have covered a truly staggering spectrum of human endeavor today. We have to try to synthesize this journey.
It has been a massive scope.
We started by looking at the oldest, deepest scars on the planet, analyzing 3-billion-year-old asteroid craters in the Australian Pilbara, and then zoomed all the way out to astronauts creating the coldest matter in the universe up on the ISS to pave the way for quantum navigation.
We examined how we are desperately deploying complex neural networks to predict catastrophic flash floods, even as those same AI architectures displace the tech workforce by the hundreds of thousands. We analyzed the intensely precarious geopolitical chess matches, from the battle over rare earth mineral refinement to the delicate, high-stakes nuclear diplomacy in Switzerland.
We saw how those macro tensions manifest on the ground, whether it is the lethal mathematics of drone warfare in Ukraine, the tragic collision of virology and war in the Congo, or the regulatory battles over the fundamental chemistry of our food in Europe.
It is a brilliant, chaotic, and relentlessly complex picture of survival.
It is. As we wrap up this deep dive, what is the core final thought we should be turning over in our minds?
I want to pull us all the way back to the beginning of our conversation. Think back to the SETI astronomers who aimed their massive radio telescopes at that ancient interstellar comet, scanning the void for any whisper of alien technology, and finding nothing but the overwhelming roar of our own radio interference.
I remember.
Consider this perspective. If an advanced extraterrestrial civilization were to turn their own diagnostic scanners on Earth right at this exact moment, they would observe a species capable of astonishing feats.
For sure.
They would see us holding matter at a billionth of a degree above absolute zero in orbit. They would see us engineering artificial intelligence to decode the chaos of our weather and theoretically designing magnetic bottles to capture the power of a star. But yet in the exact same sweep, their sensors would detect a species completely fractured, a species engaged in lethal drone combat over borders, struggling to distribute basic vaccines in conflict zones, retreating into caves to survive our own shifting atmosphere, and fundamentally unable to agree on basic reality during diplomatic summits.
It is paradox.
We are simultaneously a species of profound, godlike brilliance and aggressive, chaotic dysfunction. We are entirely a work in progress. What do you think they would make of us?
That is a deeply humbling and provocative lens to view ourselves through. Thank you to you, the listener, for joining us on this expansive deep dive. We appreciate you taking the time to unpack the mechanics of this rapidly changing world with us. Keep looking up, keep asking the hard questions, and we will see you next time.
Enjoying Artificially Informed.
Hit subscribe and share it with a friend.
From the left, the right, and straight from the algorithm.
Thank you.
Welcome to the debate. This week, China restricted the export of the world's most critical minerals. And global tech markets basically cratered.
Yeah. Absolutely cratered.
Right. And meanwhile, Iran essentially set up a mafia-style toll booth in the Strait of Hormuz.
So to the untrained eye, if you're just looking at the headlines.
Or looking at your retirement portfolio right now.
Exactly. Looking at your 401k. It really feels like the entire global order is rapidly collapsing into these isolated, hostile fortresses.
And, it's not an unreasonable fear. When you look at the sheer velocity of these events across the planet, the natural conclusion is that the integrated global economy we've relied on for decades is finally fracturing. Right, but our central disagreement today, and really the core question we need to unpack, is whether this is actually a collapse. I mean, are these crises evidence that the world is permanently fracturing into competing multipolar blocks? Or do these seemingly chaotic events actually prove that deep underlying economic interdependence continues to force pragmatic cooperation, even among adversaries?
Well, we are looking at a planetary landscape under immense pressure right now. And drawing on the latest global economic data, diplomatic movements, and geopolitical reporting, I will argue that we are witnessing a definitive multipolar fragmentation. Nations are actively decoupling. They are weaponizing economic choke points to end the Western-led unipolar system once and for all.
Okay, and I will argue that the global system is, it's undergoing a stressful but necessary recalibration. In my view, economic interdependence ultimately forces diplomatic resolutions because the cost of complete failure is simply too high for any nation to bear.
Then let's just get right into it. I know you view the interconnected market as this ultimate stabilizing force, but I think that perspective is dangerously outdated.
How so?
Because we aren't operating in a system that absorbs shocks anymore. We are operating in a system where economic connections are the actual weapons. When Iran asserts control over the Strait of Hormuz, they aren't trying to participate in the global market. They are floating mandatory insurance fees and tolls for global shipping.
Right, the insurance tools.
Exactly. And simultaneously, China is deliberately retaliating against the West by placing 10 U.S. firms, including critical rare earth producers, on an export control list. That is deliberate decoupling. It's the physical severing of the supply chains that connect us.
I don't see it as a severing, though. Think of the global supply chain more like a shared planetary electrical grid.
Okay.
When one nation suddenly overloads the system, say with sudden export controls, it causes massive, painful brownouts across the entire global economy. But that shared pain is exactly what prevents a total catastrophic blackout.
A brownout is still a failure of the system. Sure, but it forces a reset. We see this in the ongoing U.S.-Iran peace talks in Switzerland right now, which are being facilitated by Trump envoys like J.D. Vance. Furthermore, the U.S. has actually quietly eased certain oil sanctions on Iran. Why? Because a brownout forces everyone back to the negotiating table. The overarching push from all international players is towards restoring market equilibrium.
But the Middle East crisis proves those diplomatic efforts are utterly failing. Regional powers are prioritizing local dominance over global economic integration. You mentioned the U.S.-Iran Memorandum of Understanding in Switzerland as proof of stability?
Right. It's a huge step. But let's look at the reality on the ground. Despite those talks, Hezbollah and Israel continue to trade deadly fire across the border in Lebanon. U.S. intelligence is explicitly warning that Israeli Prime Minister Netanyahu is likely to actively undermine the Iran peace deal. Well, his domestic politics are certainly complicated.
Exactly. His domestic survival conflicts with American diplomatic initiatives.
I hear that. Those clashes in Lebanon are undeniably tragic. But notice what hasn't happened. The conflict hasn't spiraled into a total regional war that completely shuts down all global commerce. The grid hasn't blacked out?
It hasn't blacked out because Iran realized they don't need to destroy the grid to control it. They just need to control the switch. Iran is not playing the role of a rational market actor seeking equilibrium here.
You don't think they're acting rationally?
Not in a market sense. They are using global oil dependency as a hostage. By trapping ships in the Strait of Hormuz, they are attempting to extract geopolitical concessions through pure economic extortion. They know that disrupting a choke point that handles a massive percentage of the world's oil causes immediate global pain, and, well, they are willing to inflict it.
I'll admit, the fact that Iran is floating mandatory insurance tolls it's a massive wrench in my interdependence theory. On the surface, it's really hard to see how the market finds equilibrium around a geopolitical protection racket.
Because it doesn't.
But wait, when the initial sea lane deal was announced to reopen the Strait of Hormuz, we saw an immediate jump in oil tanker traffic. The global market instantly rewarded that diplomatic de-escalation. Oil prices declined and investor confidence surged.
You're looking at a momentary gasp of relief in the market and calling it a permanent diplomatic victory.
It's a proof of concept.
Almost immediately after that traffic jump, Iran institutionalized this toll booth. Let's look at the mechanism of how this actually works, because it's wild. When Lloyd's of London and global maritime insurers look at the Strait of Hormuz, they assess war risk premiums.
Right.
Iran knows that if they threaten ships, those premiums skyrocket, making shipping economically unviable. So Iran steps in and says, hey, pay our maritime toll and we guarantee safe passage.
Which is extortion.
Exactly. That isn't economic interdependence. That is a mafia protection racket operating on a geopolitical scale, manipulating insurance math to extract a tax on the global economy.
I see why you think that, but let me give you a different perspective on that exact mechanism. Even a toll booth requires traffic to be profitable.
Sure.
By trying to monetize the Strait of Hormuz rather than simply blockading it entirely, Iran is inadvertently acknowledging that they need the flow of global commerce just as much as the West does. They want revenue, not a completely paralyzed waterway.
They do have an inflation crisis at home.
Exactly. The minute they shut down the strait entirely, they lose their only leverage and invite a devastating military response. So they push it to the absolute limit, the brownout, but they don't flip the breaker.
They don't have to shut it down entirely to cause structural damage, though. By forcing shipping companies to pay these tolls, they are proving that the U.S. Navy no longer guarantees freedom of navigation. They are writing new rules for international waters.
But let's follow the flow of those resources. Because if Iran is bottlenecking the energy supply in Hormuz, it forces manufacturing giants like China to aggressively secure their own lifelines and retaliate economically to protect their interests. And that brings us straight into this massive tech and rare earth decoupling we are seeing this week.
Exactly. And this is where the brownout analogy completely falls apart, because China isn't just dimming the lights, they are tearing the wiring out of the walls.
That's a strong statement.
But look at the data. We are in the middle of a massive global tech sell-off. The Nasdaq and S&P 500 have tumbled. Why? Because China is actively restricting 46 U.S. firms and adding rare earth producers to their export control lists. Rare earth minerals are the absolute lifeblood of modern technology, from semiconductors to electric vehicles.
Right.
By weaponizing their dominance in that supply chain, China is executing a calculated decoupling.
I agree. The market volatility is severe. We've seen a massive semiconductor chip rout, specifically focusing on companies like Micron. But my argument is that this volatility actually proves how deeply intertwined the global economy still is.
How does crashing the market prove it's working?
Because a supply chain hiccup in one hemisphere causes an immediate, violently sharp market correction in the other. It's connected.
A hiccup? Let's explain how this is actually tearing through the financial sector. When China restricts rare earth exports, the manufacturing costs for hardware tech companies instantly skyrocket due to supply scarcity.
That's true.
That bottleneck spooks equity investors, who start dumping tech stocks because the profit margins are suddenly threatened. This isn't just a chart moving downward. It has real-world corporate casualties.
Such as?
Well, the equity rout is so severe right now that Elon Musk's SpaceX, a massive driver of U.S. aerospace, is being forced to add billions in debt just to cut interest costs and maintain liquidity.
Oh, wow.
Yeah, Musk himself lost his trillionaire status amid this global sell-off. When tech companies can no longer rely on equity markets because geopolitical export bans have terrified investors, they have to turn to high-interest debt just to survive. That is the financial fallout of major powers actively walling off their technology sectors.
I'm not convinced by that line of reasoning because it misinterprets defensive posturing as permanent severance. Yes, China is placing export controls on rare earths, and the U.S. has previously placed export controls on advanced semiconductors. It is a high-stakes negotiation playing out through trade policy.
It's a trade war.
But look at China's rhetoric just this week. The Chinese Ministry of Commerce issued statements firmly rejecting claims that they use state subsidies to undercut rivals. They are explicitly arguing that their approach focuses on promoting fair trade and adhering to international norms.
But why would you listen to their press releases when their export control lists are telling you the exact opposite?
Because the rhetoric reveals their ultimate intent. China needs Western capital and consumer markets to sustain its domestic growth just as much as the West needs Chinese manufacturing and raw materials. That is why they are defending their reputation in the World Trade Organization. A nation trying to burn the system down doesn't argue about fair trade compliance.
I think that's naive.
And regarding SpaceX, restructuring debt is a sign of standard corporate agility in a high interest rate environment, not proof that the global tech ecosystem is collapsing. The volatility we see in the NASDAQ around AI spending is simply the market trying to price in the actual value of a transformative technology after a period of intense hype. It's a natural market mechanism.
I come at it from a completely different way. If we step outside the US-China dynamic and look at the rest of the planet, the global south and alternative blocks, the evidence for structural fragmentation becomes undeniable.
Okay, let's zoom out.
Right. With the West and China clashing, the rest of the world isn't just sitting around waiting for the dust to settle. They are actively building a new, non-Western architecture.
You're referring to the movements in the global south.
Yes. Look at the recent ASEAN-Russia summit in Kazan. Southeast Asian nations adopted comprehensive declarations on energy, nuclear power, and infrastructure cooperation with Moscow. They completely undermine the Western narrative that Russia is economically isolated. In Africa, Niger just became the third state to initiate withdrawal from the International Criminal Court, citing neo-colonial repression, and that's following the Philippines and Burundi.
Right. That was a major headline.
And most importantly, look at India. India has ramped up its Russian oil imports to a staggering 2.66 million barrels per day. They are blatantly ignoring the expiration of U.S. sanction waivers.
Let's pause on India because I think this is the perfect example of where we look at the exact same data and come to radically different conclusions.
How can you see India ignoring sanctions is anything but fragmentation?
Well, let me ask you a specific analytical question. Are nations like India truly forming an anti-Western bloc, or are they simply practicing pragmatic, non-aligned economics to get the best deal?
When you openly defy U.S. sanction waivers, you are actively dismantling Western financial hegemony.
But
hold on, for our listeners, a sanction waiver is essentially permission from the U.S. Treasury allowing a country to buy sanctioned goods like Russian oil without facing secondary penalties from the U.S. banking system.
Exactly.
Those waivers expired. India is no longer legally protected from U.S. retaliation, yet they are buying 2.66 million barrels a day anyway because they know their market is too big for the U.S. to actually punish. They called the West bluff, and they won.
But why did the U.S. let them win? That's the key. India isn't doing this to make some grand ideological statement against the United States. They are doing it because they have over 1 billion people, a rapidly growing economy, and they need discounted energy to fuel their domestic development. And here is the counterintuitive insight. India buying cheap Russian oil actually helps the United States.
Wait, how does funding the Russian state help the United States?
By preventing a global supply shock. If India suddenly stopped buying Russian oil to comply strictly with sanctions, they would have to buy that oil from the Middle East or the U.S. That massive surge in demand would send global oil prices skyrocketing.
Right, it would shift demand.
And that would drive up inflation in the U.S. right before an election cycle and absolutely crush European economies. The West quietly tolerates India ignoring the sanction waivers because India refining Russian oil and putting it into the global market keeps energy prices down everywhere. It is a brilliant, silent market equilibrium.
I think that's a stretch.
It's not defiant. It's an elegant, interconnected workaround that benefits everyone involved.
That is a very generous interpretation of watching your geopolitical authority erode in real time. But even if I grant you that India's oil purchases are a pragmatic workaround, that rational economic self-interest is exactly what is driving the broader fragmentation.
How so?
In the past, Rational self-interest meant aligning exclusively with the Western financial system because it was the only game in town. Today, rational self-interest means buying Russian oil, securing Chinese infrastructure loans, and ignoring U.S. sanctions.
But political shifts in the global south are highly localized. They're not uniformly anti-US. Just look at Latin America.
Okay.
In Colombia, Abelardo de la Espriella, a rightist businessman explicitly backed by Donald Trump, just won a razor-tight presidential election. If the global south were uniformly marching toward an anti-Western multipolar alliance, we wouldn't see right-wing pro-US candidates winning national elections in key Latin American countries.
That's just one election, though.
But it shows the global south is not a monolith. It is a collection of sovereign states acting in their own rational economic self-interest, firmly embedded in the global market. Capital flows to the most efficient price point, whether that's in Bogota, New Delhi, or Kazan.
I actually think the Colombian election highlights the extreme political polarization happening within these countries, rather than proving global integration. You have pro-US factions and anti-US factions fighting tooth and nail in every emerging market, precisely because the global order is up for grabs.
It's definitely a contested space.
Right. The broader, undeniable trend is that nations like India, the ASEAN bloc, and various African states are realizing they can bypass the traditional Western choke points entirely. When a country can openly defy the U.S. and face zero economic consequences, it proves that the unipolar world order is over. The rules-based international order, where one bloc dictates the terms of trade, is being replaced by transactional, multipolar regionalism.
Well, we clearly disagree on whether this transitional phase is bending the system or breaking it, but looking at these rare earth restrictions and the maritime insurance chaos, we can both agree that the tension between national sovereignty and global markets is going to define the rest of this decade.
Absolutely.
So, to summarize my position, the global system is undeniably experiencing severe stress tests. We see it in the military brinkmanship and toll booths in the Strait of Hormuz. We see it in the semiconductor supply chain panic causing SpaceX to take on debt. And we see it in the shifting energy alliances of the global south.
And like I said, those are more than stress tests. They are structural fractures.
But the fundamental forces of economic interdependence continue to pull nations back toward pragmatic diplomacy. The fact that U.S. and Iranian officials are meeting in Switzerland, the fact that China is publicly defending its role in fair global trade to the WTO, and the fact that the West tacitly approves of India trading with Russia to keep global inflation down, all of this proves that the shared electrical grid holds.
For now.
The cost of total decoupling is simply too high. The market demands equilibrium, and ultimately diplomacy bends to the will of the market.
And to summarize my position, the evidence suggests the grid is already being dismantled. We are living through a permanent, structural shift toward a fragmented, multipolar world. The weaponization of trade is now standard operating procedure.
Mm-hmm.
When Iran uses maritime insurance risk to extort 20% of the world's oil, and when China restricts rare earth exports to specifically choke Western tech firms, they are explicitly using economic interdependence as a weapon of war.
It fundamentally changes how we understand free trade.
Exactly. Combined with the Global South's active pivot toward alternative energy and infrastructure partnerships outside the Western sphere, from Kazan to Niger, it is clear that the era of a single integrated global market is ending. Nations are prioritizing their own sovereignty, regional security, and supply chain resilience over the old models of global integration. They aren't trying to fix the old system, they are building a new one.
It seems we are left looking at a deeply complex global machinery. Is it sparking and stalling because it's adjusting to a massive new power load? Or are the internal gears fundamentally stripping themselves apart? If you are tracking your investments or just watching the geopolitical map redraw itself this week, the data will ultimately reveal whether this system is capable of recalibration or destined for fragmentation. We will leave that ultimate conclusion up to you. Thank you for joining us.
That's it for today's Artificially Informed.
Nope. Thanks for spending your time with us.
Yeah.
Stay sharp, stay curious. See you next time.